The Bible says God is revealed in His creation.
Even more amazing design in animals this week on Creation Magazine Live.
Welcome to Creation Magazine Live. My name is Richard Fangrad.
And I'm Calvin Smith.
And our topic this week is more amazing design in animals. In season 4, last year, episode 10, we did a show on amazing design in animals, and we encourage you to look that up. And the famous passage in the book of Romans, chapter 1, verse 20, demonstrates that everyone can know God exists because of what He's made, so that they are, quote, without excuse. So today we'll continue showing you even more evidence from God's creation that supports this.
Absolutely. Let's get into this. So, a seafarer has observed schools of flying fish suddenly breaking the ocean surface and gliding at great speed just above the water for short distances. They actually use their pectoral fins as wings, right? But flying squid? Yeah, the scientific community is increasingly documenting the phenomenon. Flight distances of 10 to 15 meters, that's 33 to 50 feet, by schools of hundreds of squids have been observed, flying at heights of up to 3 meters, 10 feet above the sea surface. Some of you people aren't going to be believing what I'm saying right now, but it's true.
It's true.
Yeah. However, individual flights have been reported as long as 55 meters, 180 feet, and as much as 6 meters, 20 feet above the water. Most flight observations of squid of around 20 centimeters length, but larger ones up to 1.2 meters have also been noted, with horizontal flight distances being about 50 times an individual squid body length.
There's a horror movie that could be made about this. But during flight, the squids spread out their fins and also flare their tentacles in a radial pattern to form wings, basically. Squids have a membrane between their tentacles similar to the webbing between the toes of a frog, for example. While airborne, the squid aren't simply gliding. They're not simply gliding passively. They actively change their posture. They're sort of flapping at various phases of flight.
That's right. Researchers have in fact identified 4 phases of flight. So there's launching, there's jetting, gliding, and then diving.
Okay.
Indeed, jetting, much of the flight is actively jet propelled, right? So the well-known underwater jet propulsion abilities of squid serve them not just in launching themselves from the water, but in further accelerating themselves once they're airborne.
Yeah, amazing. Prior to launch, the squid hyperinflates its mantle with water, and a sudden contraction of the mantle then forcibly expels water through a directionally controllable, flexible, narrow funnel, and they blast themselves from the sea into the air. That's amazing. When the high-pressure jet of water runs out, they glide. Until ending their flight with a controlled dive back into the ocean, first folding in their fins and tentacles back in to minimize the impact. Flights are generally about 4 seconds long.
Right. And one study reported flying squid acceleration in air being up to 3 times greater than in water, with flying speed while under jet propulsion being up to 5 times faster than when they're traveling underwater. And electronic tagging has shown that squid are traveling the long distance migration routes much faster than anyone else thought possible. That's why they figured out these things were moving this way.
Right, yeah. Biomimetics researchers have now added flying squid to the creatures that are inspiring them to design and develop improved robots and drones, for example. Engineers have lamented that although good progress has been made in separately developing micro underwater vehicles and micro aerial vehicles, saying, they say this, no technologies are available that allow them to both dive and fly due to dramatic design trade-offs that have to be solved for movement in both air and water due to the absence of high-power propulsion systems that would allow transition from underwater to air. In nature, several animals have evolved design solutions that enable them to successfully transition between water and air and move in both media. Examples include flying fish, flying squid, there it is, diving birds, and diving insects.
Right, so evolved?
They evolved.
Actually, just as the engineer's own designs come from careful designs, so too should the flying squid's multimodal aquatic aerial capabilities.
Of course.
The envy of highly intelligent engineers, they're the product of intelligent design.
Yes.
A very intelligent design, and that very intelligent designer made us as well, and we should give him credit accordingly. And we'll be back shortly.
Most people don't like to be told they have a big head, but some scientists might actually consider that a compliment. Humans have much larger skulls than apes, and since humans are much more intelligent, there's been a long-standing belief that skull size indicates level of intelligence. That's why evolutionists tend to interpret slightly larger ape skulls as advanced apes, and slightly smaller human skulls as subhuman. But this evolutionary story has multiple problems. Neanderthals were supposedly primitive, often portrayed as subhuman, but their skulls are actually bigger than ours. Also, the winner of the 1921 Nobel Prize for Literature had a tiny skull, 25% less than today's average volume. The reality is that skull size is a poor intelligence indicator. After all, the average skull size of men is greater than that of women, although there is no consistent difference in intelligence.
To find out more from Creation Ministries International, visit our website, creation.com.
All right, welcome back. If you just tuned in, we're talking today about amazing design in animals. Now, we just looked at flying squids. Amazing. Let's look at another animal, woodpeckers. Woodpeckers hammer wood with their bills, in case you're not familiar with what these things are. They drill holes into trees when foraging or to excavate storage holes or cavity nests. The pecking impact forces are huge. The woodpecker's head suddenly comes to an abrupt halt when the beak hits the wood, obviously, resulting in deceleration forces of like 1,200 Gs. That's 1,200 times the force of gravity. And this repeated head bashing, around 18 to 22 times per second or so, doesn't result in blackout or brain damage. Now, in stark contrast, just 300 Gs will leave a human with a concussion or serious brain injury.
Right. Now, a major challenge confronting engineers has been the need for a new shock-absorbing system for protecting micro devices. Amazed at the woodpecker's head-banging resilience, a team of engineers investigated its advanced shocking absorbing mechanism. With the help of X-ray computed tomography, CT scan, images of the woodpecker's skeletal structures, the engineers highlighted its shock absorbing features. The beak is made of elastic material. The hyoid, the muscles and tendons supporting the throat and tongue and reinforcing the head, they noticed this spongy bone especially located around the beak. There's a special skull bone containing spinal fluid. And these features stand in a row. They're sequential. There's sequential cushioning and dissipation. They dissipate the mechanical excitations, preventing brain injury. Other researchers confirm that it's the combined effect of these features that confers the protection rather than any single factor. So they all have to be there to convey that protection.
Right. Inspired by the woodpecker's shock-absorbing spongy bone and hyoid, the engineers used the same principles with metal and elastic substances to design a shock absorption system to protect commercial micro devices. When tested at 60,000 Gs, the woodpecker-inspired technology reduced the failure rate of micro devices to just 0.7% compared to 26.4% for conventional shock absorption methods. That's a great design improvement, obviously. The same principles from woodpecker anatomy could guide design of even more effective helmets, for example, and protective headgear, that kind of thing.
Well, it looks like engineers can recognize good design when they see it.
I guess, yeah.
And so should all of we, a la Romans 1:20.
Yeah.
We've often reported on human designers copying the designs found in nature. One promising field is how organisms generate and manipulate light. So bioluminescence. Let's talk about bioluminescence.
Right.
Such as in fireflies and
fireflies.
octopuses. They generate light from chemicals very efficiently.
Fireflies are actually not flies, but beetles. They use bioluminescence to produce light in their lower abdomen. The light is produced by a chemical called luciferin and is found in special cells called photocytes. In addition, it also requires an enzyme, luciferase, magnesium oxygen, and energy via ATP produced by the world's tiniest motor.
That's right. There are 3 layers here. There's the cuticle, kind of the window, the photogenic, which is the light producing, and a dorsal layer. So the photogenic layer produces light in all directions. This either passes through the cuticle directly or after reflecting off of the dorsal layer. This is extremely reflective because it's a finely layered structure called a dielectric mirror.
Okay, and the window itself also has an amazingly fine structure. Now, normally when light passes through a boundary between different materials like glass or whatever, some is lost through reflection. This can be minimized through a process called optical impedance matching. It turns out that the cuticles on the firefly lanterns section have a very fine structure that does exactly that. It has a very tiny ridges, 150 nanometers in width and 110 nanometers in height, in a period, the distance between one high point to the next, of 250 nanometers. So 1 inch is 25.4 million nanometers, just to give you an idea of the size of this. It's extremely small. This turns out to be the best dimensions to transmit the most light at the firefly's peak wavelength, yellow-green, through that layer. Incidentally, our eyes are the most sensitive to that same color.
Right. Now, researchers at the Biophotonics Lab of the Korea Advanced Institute of Science and Technology, led by Ki-hun Jeong, have duplicated this structure for an LED lens. This enabled 3% more light to be transmitted than a smooth lens. This sounds small, but in the quest to maximize energy efficiency, it's a good start. The researchers say the biological inspiration can offer new opportunities for increasing the light extraction efficiency of high-powered LED packages.
Yeah, now of course the report made the usual fact-free homage to evolution, claiming that efficient versions of these nanostructures have been selected for over hundreds of millions of years, but the practical research used design principles to duplicate these nanostructures.
Right.
So if the plagiarized copies required brilliant design, how much more would the originals?
The reason that the Creation Answers book is so popular is because it covers a huge range of topics and answers more than 60 of the most asked questions about Genesis and the creation evolution issue. Questions like, what is the evidence for God's existence? Could the days in Genesis 1 be long periods of time? How did all the animals fit on Noah's Ark? Does radioisotope dating prove that the Earth is very old? Where do dinosaurs fit into the Bible? And many more. To order your copy, visit creation.com.
On this week's episode, we're talking about amazing design in animals.
That's right. Well, as a fun little aside here, current news reports cite a recent scientific paper sounding like the premise for a B-rated horror movie. Tree-climbing crocodiles. The paper's abstract reads this. Climbing behavior is common among crocodilians. So, although this might be a little disconcerting for readers and especially bird watchers, you can imagine that.
Can't imagine.
You picture a 600-pound crocodile or something stalking you from above. Actually, the observed crocs were primarily juveniles.
Okay, that's good. However, the paper reports claim seeing crocs as high up as 30 meters, and said this: a 1.4 meter individual was seen basking at the end of a fallen tree about 5 meters out from the bank and 4 meters above the surface of the water. To reach this site, the crocodile would have had to scale a 4-meter, completely vertical bank and then walk amongst the branches to reach the end of the tree.
So this kind of unexpected animal activity in creatures, it should really, that are alive today, it should remind us to be cautious when we hear about these hypothetical historical accounts of how extinct animals should have behaved and all that kind of thing.
Right, yeah. I mean, between the flying squid and tree-climbing crocs, who knows what we're going to see next, right?
That's right. Now, camouflage. It's an incredible design feature used by many creatures to protect themselves in this dangerous, sin-cursed world we live in.
Right.
So typically, whatever the specific camouflage ability is, it's usually used to mimic either the environment in which the creature lives or in order to hide or to impersonate a particular predator that could scare other predators away. However, 2 independent studies have revealed a creature that mimics itself. And one could say it does so in a big way.
Yeah. In the year 2012, that was when 2 U.S. biologists discovered an amazing behavior in 2 different species of spiders, believed to be from the Cyclosa spider family, living 11,000 miles apart. One lived in Peru in the Amazon basin and the other in the Philippines. The scientists discovered the spiders using forest debris, things like bark and leaves and moss, and even the corpses of insects from the jungle floor to create visual replicas of themselves in the middle of their webs.
That's right. These copies are incredibly detailed, complete with 8 arms and the general layout of a spider body. The only major difference in appearance was in the dummies. They were about 10 times larger than, the spiders that created them.
Right.
So the result was an astonishingly realistic image of a giant spider that provided either a menacing appearance to creatures that might have dared to, pick on the smaller spider, or that provided a false target for undeterred predators that mistook the decoy for, the real owner of the web.
Right. To add to the realism of the imitation spiders, it was found that not only did the real spiders build such realistic decoys, but they also caused them to move when predators were near by shaking their webs. They made their doppelganger creations appear to come to life. Not only is this behavior fascinatingly complex, but it also seems unprecedented in the animal kingdom. No other example of a creature creating a larger decoy of itself to escape being eaten seems to exist at this point.
That's right. A quick internet Google search with keywords spider decoy will reveal several articles on these creatures, and an image search will display hundreds of pictures of the creatures and their zombie-like creations. Inevitably, they always have this hand-waving mention of evolution thrown in to, try to explain these incredibly sophisticated activities in such a primitive creature,
right,
naturalistically. Biologist and science educator Phil Torres described the find from his evolutionary standpoint this way. It seems like a really well-evolved and very specialized behavior. Considering that spiders can already make impressive geometric designs with their webs, it's no surprise that they can take that leap to make an impressive design with debris and other things.
It's no surprise, yeah.
Yeah.
But is it really that easy? There are only 2 ways to explain the spider's habits: instinct or learned behavior. Either construction of these spider decoys, along with the puppeteering of them, is programmed into the creatures genetically, right, or the spiders are thinking through their actions. Does either of these explanations make any sense naturalistically? We'll continue with that when we get back.
When the BBC produced the Walking with the Dinosaur series several years ago, they had to search the globe for appropriate filming locations. But whenever they discovered an otherwise suitable site, the ground was inevitably covered in grass. And back in the year 1999, that was an evolutionary impossibility. You see, until recently, most scientists thought that grasses first evolved around 55 million years ago, long after the supposed extinction of the dinosaurs. But since then, studies of fossilized dinosaur dung have shown that not only did dinosaurs and grass live at the same time, but dinosaurs actually ate it. We often hear dogmatic statements about what did or didn't happen millions of years ago. But it's important to realize that these statements involve lots of assumptions, are often based on fragmentary evidence, and can be totally overturned when new evidence comes to light.
To find out more from Creation Ministries International, visit our website, creation.com.
Well, our subject today is amazing design in animals, and we were just talking about whether these spiders' habits, whether they were instinct or learned behavior. So let's see about this. How could evolution account for spider duplicate instincts?
Okay, well, evolution's mechanisms fall broadly into 2 categories: natural selection and genetic mutation. Mutations are supposed to create new genetic information, while natural selection is supposed to select from the information that provides a survival benefit for the organism. That's the theory.
Right. So assuming that these spiders, there were once spiders that didn't build spider decoys, what kind of mutations would cause spiders to do so incrementally?
Right. Yeah. Well, perhaps an initial genetic mutation affecting behavior somehow developed in a group of spiders that caused them to randomly gather and arrange simple clumps of debris in their web.
A hoarder gene.
Yeah, a hoarder gene. Yeah. Then later, maybe more mutations accumulated that caused them to arrange the clumps of debris into more of a spider shape. But never mind how the genes were activated at the precise stage of development needed to integrate this into their behavior and the programming and affecting their central nervous system. Well, let's just put that aside for now.
Right. Well, supposedly we finally get mutations that involuntarily cause them to arrange debris to look like legs. They just decided to do that, right? Until finally they settle on the number 8, because the spider decoys have 8 legs. And so remember that all the wild, these spiders, they're not cognitively aware that they're doing this, right? These are just instincts like breathing, etc.
Yeah.
So then they get a mutation that causes them to shake their web, which moves the decoy, which it isn't really aware that it is a decoy, because this is just instinct. So, there's this fortuitously, frightens these predators. And then later on, they get more mutations causing them to only shake the web when they detect danger. So that's kind of like a if an A, then B type program. And that just naturally.
Yeah, this scenario just described is an example of kind of a typical evolutionary explanation to why we observe creatures like decoy spiders in the present, for example. But it's a fine illustration of why the creation-evolution debate is in the realm of historical, not operational science. Right. No one ever observed the types of changes described, and this really is just an example of evolutionary storytelling. Yep. If you believe it happened like that, you believe it by faith, not by observation.
Yes, as famous evolutionist Ernst Mayr once said, evolutionary biology, in contrast with physics and chemistry, is a historical science. The evolutionist attempts to explain events and processes that have already taken place. Laws and experiments are inappropriate techniques for the explication of such events and processes. Instead, one constructs a historical narrative consisting of a tentative reconstruction of the particular scenario that led to the events one is trying to explain.
Good definition. Web building might be explained away as a series of repetitive, instinctive movements, but constructing a highly detailed replica of yourself and hiding behind it or beside it, and then manipulating it so that it looks as if it's alive when danger is near, is incredibly sophisticated. Yeah. To believe that that kind of programming instinct could come about by random mutations takes a great deal of faith.
Yeah, now the other option here, of course, is that these spiders are thinking this through, right?
Okay,
they're deliberately
so let's play that through.
Manipulating the world around them to a level that really only human beings have ever been observed doing, right?
Right.
So in order to create a decoy of itself, it would have to know that it's a spider in relationship to other things. It would also have to make the connection between a spider in the abstract and a spider that it is.
Right. It would have to recognize that it was in danger from predators and that a duplicate of itself might trick those predators. It would have to understand that making a larger spider would be better than a smaller one, for example, to scare certain predators and be more of a target for other ones.
Right. But it would have to understand that movement indicates life, so that it would, knew to manipulate the dummy when predators were near in order to, flee or entice the predators to attack the duplicate instead of itself.
Yeah. Like a farmer setting up a scarecrow, it would have had to reason through its own experiences to make the conclusions about the future by using the information in the present to make decisions about how to best look after its own interests. Amazing.
But because of the size of the spider's brain and the limited behavior that spiders actually exhibit, no scientist seems to be seriously suggesting that spiders think through the idea to create a copy of themselves to help keep themselves alive. The programming to build the decoys seems to be a programmed instinct into the DNA of the spider.
Right, but programs require a programmer. It makes far more sense to believe the decoy spider was designed and programmed with the ability to create this functional sculpting ability, and then it is to think that it evolved by chance.
Right. So there's out of your two possibilities there. It makes a lot more sense to. We know this stuff. Computers are programmed. There's this, we deal with this stuff all the time. Again, this isn't some kind of, we're just saying that God must have done it because we don't have an explanation. We know where programming comes from. We know.
It comes from programmers.
Exactly. So. again, and we'll be back.
Richard Van Grad and Calvin Smith also host a fast-paced and informal internet-based video program called Genesis Unleashed. These faith-building teaching videos feature responses to news articles, summaries of articles on creation.com, interviews, and answers to some of the most asked questions about the creation-evolution issue and the most attacked book of the Bible, Genesis. Visit creation.com's media center to view or subscribe to the latest video content.
All right, as we wrap things up here, we're going to look at a feedback, an email that came into our office. It starts this way. I have a question about a specific part of the Bible. I was Catholic until 9, and then I reread the Bible throughout. Why would God not allow Adam and Eve to eat from the tree of knowledge? This must mean that God was restricting free will and Adam and Eve were punished for gaining knowledge and learning something new. As a curious 15-year-old who questions everything, that seems illogical and incorrect to my beliefs that one should be allowed to think and challenge beliefs when they see fit. This seems fundamentally incorrect. In this website, talking about creation.com here, you provide evidence provided by scientists that are learning something new. How do you justify the fact that in a literal sense, God disallowed the gaining of knowledge, but yet you are using knowledge that you apparently found out and inferred from ideas you created? Does this mean you are moving away from the words of God by learning new things? Please respond. I would like to debate about morals and beliefs of the Bible.
Right, and Information Officer Lita Costner responded, your question assumes that knowledge in and of itself is always a good thing, but a little bit of reflection will reveal that this is not so. For instance, it's not good to know what a broken leg feels like, because even though you've gained knowledge, it comes at the cost of intense pain and damage to your own body. It's not good to know what it feels like to hurt another person for the same reason. We know all sorts of things that we wish we didn't because of the pain, embarrassment, and the moral guilt attached to it.
Right.
In the Garden of Eden, Adam and Eve were morally faultless. They were in a perfect environment where all their needs were met. They had pleasant work to do, and best of all, they were in a perfect relationship with their Creator. They had no reason to question His goodness or truthfulness. He told them not to eat from the tree of knowledge of good and evil because it would be fatal for them. The serpent spun it a different way. He claimed God wanting to keep something good from them. Which, by the way, is the way you're reading it too.
Yes.
So the sort of knowledge gained in science or academic study is fundamentally different. God wanted Adam and his descendants to have dominion over creation. That likely included learning about creation and harnessing it for human good. That means that science is well within what God intended us to do.
Right.
So she adds this one little bit at the end, and she said, I want to challenge you a little bit. You're a 15-year-old, and you claim the right to challenge what you perceive as illogical and fundamentally incorrect, but your level of education and life experience, you're very ill-equipped to judge these things. You need to spend more time to serious study before challenging anyone to a debate, which is good advice for young people sometimes. So our show here is based on Creation Magazine. A lot of the content we provide here, Flying Squid, for example, you could find that in Creation Magazine.
Came right out of the magazine.
Yeah, you can get yourself a free copy of Creation Magazine if you go to our website, creation.com/free-mag. That's going to allow you to access a free copy of Creation Magazine.
Yes.
Next week on Creation Magazine Live, everyone lives by faith, even atheists. See you next week.